Hi, welcome back. And in the today's session, we continue the discussion on the clustering. So in the today's sessions, we try to understand the basic concept of the k-means algorithm, and then we try to understand how we're going to determine the value of k in the k-means algorithm. So what is the k-means clustering? K-means clustering is one of the popular non-hierarchical clustering algorithm. So if you remind what we discussed in the last sessions, we took a look at the hierarchical algorithm, especially hierarchical agglomerative algorithm. But in today's session, I'd like to introduce another type of the clustering algorithm, k-means algorithm. That is the non-hierarchical clustering algorithm. And this algorithm is one of the popular algorithms in practice. So for example, you specify the number of clusters you'd like to have. So you need to tell the algorithm to say, I'd like to have the k number of clusters. So that is the kind of parameter you need to tell the algorithm. So in case of the 3, in this example, the k is equal to 3. So based on that, informations, algorithm try to identify the 3 cluster. So k stands for the number of clusters, and as already mentioned that it is typically a user input to the algorithm, but sometimes there is some criteria and which can be used to automatically estimate the value of k. Right, so this slide shows some example of the k-means clustering, and actually this is kind of example of the clustering problems. So the clustering can be used to the group some species of flower as like this, or it can be used to analyze the market segment. So you can cluster depending on some characteristic we have on the data. Okay, so in this slide, I'd like to talk about what the cluster means mathematically. So I'd like to introduce the mathematical definition of the clusters. So cluster is nothing but the partition of the data point into the k number of the clusters. So for example, clusters need to satisfy these 2 conditions. The first condition is the union of the k cluster supposed to be equal to the all data point. So each data point belongs to at least one of these k clusters. And second one is if you consider 2 different clusters, the intersection of the 2 clusters must be null set. In other words, the clusters are non-overlapping. So no data point belongs to more than 1 cluster. So that is nothing but the partition of the data points. Basically, k-means algorithm, the minimize within cluster variation for k clusters. So let's say with W refers to the within cluster variation, which is the function of the each clusters. And within cluster variation is defined by the pairwise sum of the square Euclidean distances. Right? So in this case, you need to calculate the difference between 2 data points within the certain cluster CL, right? Yeah, you need to calculate the distance between 2 data points, and then you just take the square, and then you just sum them all. And that is defined as the within cluster variations. And if you consider the within cluster variation for every k cluster, and that is the within cluster variation for k clusters. And this algorithm tries to minimize this within cluster variation for k clusters. So the k-means clustering algorithm tries to find out the cluster that satisfies, that minimize, this, within cluster variation for every k cluster. Okay, so in this slide, I'd like to briefly provide you how this k-means clustering algorithm works. So in the initialization stage, we need to choose k data points to be an initial centroid, or the center of each cluster. Or you can place the k centroid in the random locations. Either way will be fine. Right? And then we keep doing this two-step iteratively until there is no more changes in the cluster assignment. So we're going to talk about what does main means later on. So basically, given the centroid, what you need to do, you need to assign each data point to the cluster whose centroid is the closest. What does that mean is, for each data point, you need to calculate the distance for the k centroid, and then try to find out the closest centroid. And you identify the centroid, you assign that point to the centroid, right? And once you finalize the assignment for every data point, then what you need to do, you need to recompute the cluster centroid again. So you need to calculate the average or mean of the data point containing to the same cluster. So you keep doing this until there is no more changes of the cluster assignment. So, it's better to illustrate how the algorithm works through the example. So let's consider this data set, right? So by using this example, I try to illustrate how the k-means clustering algorithm works. So in this case, we set the k equal to 2. So let's say we have the k is equal to 2. So that means the user wishes to have the 2 clusters, right? And the first step, in the initialization step, we randomly assign the 2 data point, or you can place the initial centroid randomly in the two-dimensional space. So let's say we have the 2 centroid. So we place the centroid in the random locations. And in the first step, we need to compute and see which data point is closer to which centroid. So for example, so what you need to do, for each data point, you need to compute the distance, right, between the red centroid and the yellow centroid, and then try to identify which centroid is closer to this data point. And you need to assign this data point to the closest centroid. In this case, this data point is supposed to be assigned to the red centroid. If we keep doing this, we will have this result. In other words, we keep calculating for the distance between 2 centroids for every data point, and then assign the closest centroid. This is the outcome of that operations. So you can virtually draw this kind of the line, and everything on this side of the line is closer to red centroid, and everything on the other side of this line is closer to the yellow. That means all the data points on this side are going to be assigned to the red centroid, and all the data points on this side are going to be assigned to the yellow centroid. And in the next step, what we need to do, we need to recalculate the cluster centroid values. So we need to update the cluster centroid. So what we need to do, you need to calculate the average of the all data points that were assigned to each centroid. For example, for this data point, you need to calculate the average of all the data point, the red dot, and then you need to come up with the new centroid, which is this. So centroid is changed from this to this for this cluster, right? You do the same thing for the yellow dots, right? For the yellow dot, all the point of the yellow dot, you need to calculate the average. And that will be the new centroid, right? So yellow dot, yellow centroid will be moved from this to here, all right? So you have the new centroid. And what we need to do, with the new centroid, you do the same thing, right? For each data point, you need to calculate the distance between two centroids. For example, this one, for this data point, you calculate the distance with this yellow centroid and the red centroid, and it turns out that this data point is closer to yellow centroid. Then you need to assign this data point to the yellow centroid, right? And this is what we have as a result. So all the data point on this side supposed to be assigned to the yellow, the centroid, and all the data point above belong to this the red centroid. So what we need to do in the next, we just again calculate the new centroid, which are assigned to the same cluster. So by using the data point on this side, you just recompute the centroid. And with this the data point, with this the red data point, you just recalculate the centroid. And what we have is we're going to have the new centroid, right? And again, we do the same thing. What we need to do, for each data point, you just calculate the distance between each data point to each centroid, and then assign the data point to the closest the centroid. In this case, this data point is supposed to be assigned to this yellow centroid, right? So you can do it, and then eventually what happens is there is no more changes. There is no more change of the cluster membership. So we finally get to the point where no data point is going to change the assignment, or no point is going to move from one cluster to another cluster. Then all the performance, all the k-means clustering algorithm finishes. Okay, so far we've discussed the algorithm of the k-means clustering algorithm, and we're going to move on to the next topic, which is the next question of how we're going to decide the k. So one of the main issues in the clustering algorithm is how we're going to determine the number of cluster k. So there is no right choices of the k. So obviously, we can simply try the different value of k. For example, we can try the clustering with the 2 clusters, 3 clusters, and 4 clusters, and then see what looks good. So, somebody say this is better, or somebody say this is better, and somebody say this is better. So, there is the choice of the proper k often, ambiguous, or sometimes the decision is supposed to be subjective. So it depends on the shape and the scale of the distribution of points. And indeed, there are several categories of method for making such decisions. So there are several methods for determining the k. So as a rule of thumb, the k is normally calculated in this way. You take the square root of the half of the data points. And this is kind of a rule of thumb, but basically there are other methods to determine the proper k, the proper value of k. So the SILAB method, ALBA method, information criterion approach. So there are many approaches, right? So in this case, I'd like to introduce a silhouette method. Silhouette method is to calculate the silhouette value, which is the measure of the how similar an object is to its own cluster compared to the other clusters. And the silhouette value ranges from the -1 to the 1, and we prefer to have the higher values. So higher value of the silhouette value indicate the object is well matched to its own clusters, right? So what we need to do, you just change the value of k and then calculate the silhouette value, right? So for example, for the same data point, all right, okay, this is a case of the when k is equal to 4, right? And then this is the case when k is equal to 5 for the same data points, right? And when the k is equal to 4, all the silhouette coefficient value are above the 0.6, and normally the silhouette value is above the 0.5. I mean, the clustering is good. And in this case, when the k is equal to 5, in the cluster 2, the silhouette coefficient value is less than 0.5, 0.6. So I will say when k is equal to 4 is better than k is equal to 5. So still, this is also subjective, and the silhouette method only give us some guidance about which value of k is better than the other k's. Right. So I'd like to talk about the strength and weakness of the k-means clustering. The strength of the k-means clustering algorithms are as follows. So it is easy to understand and easy to implement. And when it comes to efficiency, computational efficiency is fairly fast. So time complexity is dominated by the number of data points times number of clusters times number of iterations. All right? How are we going to think about this one? Because you need to think about how many calculations do we have. So you do, for each data point, for each iteration, you compute the distance between the data point and then every the centroid, right? And you do the same thing for every data point, so that the n times k comes from that calculation procedure, and then you do the same thing for every iteration. So I multiply by t, which is the number of iterations. So when the k and t are small, k-means is considered as a linear algorithm, so it's quite fast, right? On the other hand, there are several weaknesses of the k-means clustering algorithm. An algorithm can be applicable only if you can calculate the mean, right? So if you think about the procedure of the k-means clustering algorithm, for each iteration, we compute the average of the newly formed cluster, the data point, right? And what we do, we try to calculate the average. So if you cannot calculate the mean, you cannot calculate the new centroid, so you cannot proceed the algorithm. So algorithm can be applicable only if you can calculate the average or mean. And still, one of the weaknesses of the k-means algorithm is you need to still choose the proper number of clusters. And still, and the algorithm is sensitive to outlier because, in statistics, normally the mean, calculation of the mean is sensitive to the outliers. So because of the K-means algorithm also compute the average, so that's why this algorithm also sensitive to the outliers. All right, so in this week, I introduced the what the clustering problem is, and clustering is grouping similar samples together. And basically, we prefer to have the clusters having the high intra-cluster similarity and low inter-cluster similarity. And I introduced two types of algorithm. One is the hierarchical clustering algorithm, specifically hierarchical agglomerative algorithm, and the K-means algorithm, which is one of the popular non-hierarchical clustering algorithm. All right, so that's it for today. Thank you.